We're going to look at examples 3 and 4 in your section 4.9 notes. Before we start example 3, we're going to look at the indefinite integrals of the trig functions. So if we're trying to find the antiderivative for cosine, it's sine. Okay. For secant squared, it's tangent. And for secant x, tangent x, it's secant. Okay, definitely do a quick check. Try to take the derivative of each one of these, and you should get the function next to the integral sign. Okay, if we're doing the antiderivative of the sine function, it's negative cosine. Remember, the derivative of cosine is negative sine, so we need this extra negative to cancel out. Okay, same thing for cosecant squared, its antiderivative is negative cotangent. And for cosecant, cotangent, its antiderivative is negative cosecant. Okay, so in example 3, we have the function, the cosecant squared of theta plus 1. Okay, so we can definitely separate this from what we learned in theorem 4.17. Okay, so I have the, try to find the antiderivative of the cosecant squared theta, d theta. And then plus, I have 1, okay, d theta. Okay, so if I look at my box, I try to see where I have a place where I'm trying to find the antiderivative of the cosecant squared. Okay, and I see that right here. So my answer is going to be negative cotangent of theta for that part. Okay, next up here, okay, so just like what we did earlier, think about this as theta to the 0 power. That is an answer of 1. So we need the power rule here. So if we add 1 to 0, we get theta to the first power, okay, or just theta. And of course the reciprocal is 1, all right? And then don't forget the plus c to get the family of antiderivatives. And that does it for example 3. All right, next up for example 4, we're going to have another table of indefinite integrals that we're going to run through real quick. So the antiderivative for e to the x is itself. It's probably our nicest derivative too. If we have, we're looking at the antiderivative 1 over the square root of 1 minus x squared. Remember that comes from sine inverse. Okay, so this one here, 1 over x times the square root of x squared minus 1. That's the secant inverse of the absolute value of x. Okay, if we're trying to take the antiderivative of 1 over x, it's the natural log of the absolute value of x. And then the antiderivative of 1 over 1 plus x squared, that's antiderivative is tangent inverse of x. Okay, so in example 4, we have to recognize which one it is from our box here. And it looks closest to this, except for we have a 3 instead of a 1. Okay, remember constants can be pulled out. So we have the 3. So you can go ahead and take that out. So you can match it up, okay, with this one right here. So we're going to have 3, and the antiderivative of 1 over x is the natural log of the absolute value of x. And then don't forget the plus c. Okay, and that does it for example 4.